Hello, everyone. Today we're going to be looking at kind of just an addendum. It's something that I need you to see for 1050, 1060 in calculus, but it's not something I'm going to be testing, and there's not even going to be any homework on it. But I do want you to see it. I do want you to understand at least a little bit of it, what's going on, just so you're prepared for when you get to 1050, 1060 specifically. So we've dealt with A, we've dealt with B, and we've dealt with K. Okay, now if you remember from the Desmos activity that we did, we also had that H slider, and H slid the graph horizontally. We call that shift in sine and cosine and tangent a phase shift because there is a phase, right? Kind of like our period, and we're just taking it and we're shifting it over a little bit. Okay, now for this equation, though, we have to be very careful because we do want B to not be with X. So we're going to look at an example a little bit later where B is inside with X, and we don't want that. We want to make sure we pull that out. But it should look like this. Okay, and again, just kind of a quick, here's how it works. So you can see that. Same idea. We're going to have our midline at +3. In this case, we've got an amplitude of 1. Our period, I can put parentheses right around this and put a 1 here because multiplying something by 1 doesn't change it. Even multiplying multiple things by 1 isn't going to change it. So I've got 2 pi over 1 or just 2 pi. Okay, and then what happens is we get a phase shift. Let's go with orange for this. And we've got a phase shift. Now, the thing with the phase shift is, remember for the period, right, it kind of did the opposite what made sense. If we had 2 or 3 or 4, it started compressing that curve in. And then if we had a half, it actually kind of stretched it out, which was counterintuitive. And that's because it's inside with X. So just like going back to when we did parabolas and things like that, where it kind of did the opposite of what made sense, where we would have a shift to the left when it was positive and a shift to the right when it was negative. That's what's going to happen here. So if it's negative, it's going to go the opposite direction of what makes sense. So the best way to do these is to start off the same way. So 1, 2, 3. Okay, with an amplitude of 1. So up by 1, down by 1. Okay, now originally, my period would end at 2 pi. Okay, and then my sine curve would look something like this. Oops, let me draw it a little better. Let me actually cut that in half, and cut in half again, so I have a nice, there we go, that's gonna be better. Okay, and I'm doing a dotted line here for a reason you'll see in a second. So my sine curve would look something like this. Okay, but again, we have this phase shift. So instead of being existing right here, it's going to exist over by pi over 2. So cutting this up, right, this would be pi. This would be pi over 2. This would be 3 pi over 2. Okay, so instead of starting at 0, because it's not just the end that shifts over, it's also the beginning that shifts over by pi over 2. So instead of starting at 0, I'm going to move over and start at pi over 2, which means this point would then move over, and the middle point here would move over, and so on and so forth. Okay, but I do need to add one more spot for 5 pi over 2. So now my function, instead of existing there, is moved over, and this is the one you would want to draw. Oops, let me draw that better. And it looks like this. Okay, so all it did is really it just took it and it shifted it over in one direction or the other. Big thing to remember is that it does do the opposite of what makes sense. So if I have a negative, I go to the right. If I have a positive, I go to the left. Okay, now typically your equation is going to be set up like this. Okay, we do not want to take this and distribute it. This is actually how we want it set up. If I go back to my original equation, I mean, that's what it looks like, right? So I'm actually going to skip over that one. Again, we're not going super deep into this. And I want to look at this one. So for this one, it's not set up because I don't have a 1 in front of that x. I have a 1/3. So I'm going to take this middle part here and just rewrite it over here real quick. I'm going to say 1/3 x plus pi. Okay, now I can factor out a third here by taking 1/3 out of each part, right? And then I can put that out front. 1/3 divided by a third is just 1, which is what we wanted. And then pi divided by 1/3, pi times 3/1, KFC, is going to give me 3 pi. Okay, and then I can take this and I can substitute it back in. So I've got negative cosine, bracket, minus 2. Okay, and again, I would just plot this kind of like I did on that first one. But again, the idea here is just so you've seen this. I'm not looking for a deep understanding. Again, it's not going to be tested on. There's not any homework on it. I just wanted you to kind of see it so you'd be prepared when it comes back up and go, okay, yeah, I kind of remember that. We talked about that briefly, so that it's not a super big surprise. So again, the idea is just we're taking that sine curve or cosine curve and we're just moving it over a little bit, okay, one direction or the other. Okay, that's it for this one. Again, not being tested on this, just showing you, but I did want you to see it. So here it is, and I will see you guys next time.